Define density and pressure. Okay, so we know that density is defined as mass per unit volume. Pressure is defined as the normal force acting per unit area or on a unit area. In part B, you're asked to use the definitions, okay, from above, and to derive this equation P equals to H rho G. Okay, by the way, this is a Greek symbol, this one, rho. You read as RHO, rho. Okay, one of the Greek symbol. So you're asked to derive this equation for the pressure P at the depth H in a fluid of density rho. So let's consider a container which contains the fluid. You're told that this height here is H. The density of the fluid is rho. Okay, so that is the density of the fluid. So I want to derive the formula for pressure P. So we start with the definition here. Pressure is defined as normal force acting on a unit area. So I'll take force over area. So the force, right, acting on the base of the container or the base of the fluid here will be due to the weight of the fluid. So the weight of the fluid will be the mass over the area. Okay, but I am not given the mass. So if you look at the definition for density, density is defined as mass per unit volume. So I have rho equals to mass over volume. And that is to say my mass of the fluid will be the density times the volume. So I'm going to use that formula here. So instead of mass, I replace it with rho Vg and divide by area. But again, I'm not given the volume. Okay, I have the height instead. So I'm going to use the formula volume equals to the, okay, this will be the base. Let it have an area A will be the area over H. So this A, right, is the same as the area here that we are referring to. Okay, so it's per unit area of the base of the container. So from here we have rho A H G over A. Then A is common on top and below, cancel that off. So I'll have H rho G. So from here we can see that for the pressure of fluid, it is dependent only on three factors, which is the height, the density, and the G, gravitational field strength. Okay, let's move on to part D. Which point has the highest pressure? Explained. Okay, in this question, we can see that the height of the fluid, right, for all the containers are the same, although they have different shape. So you have different mass of the water acting on the points. However, from the derivation above, we know that the pressure, right, is only dependent on H rho G. Okay, they are using the same fluid, so the density is the same. Using it's conducted on Earth, right? So the G is also the same. So the only other factor that affect the pressure will be the height. So all of them have the same height, therefore all of them have the same pressure. So to answer this question, all points have the same pressure, because heights of the fluid are the same. Okay, so heights of the fluids are the same. Same density because same fluid. And G is definitely the same. So the only deciding factor would be the height.